Hi dear student friends. So, in the last so myself Manjunatha PC, Senior Assistant Professor, Department of Computer Science and Engineering, so Reva Institute of Technology and Management, Yelahanka, Bangalore. So, I will be taking you on the concept of so functions, arrays and strings. Before I proceed, in the last session, so we have seen the lab program of rotation of a binary digits bit rotation of a number, integer, unsigned integer number. So, and then we have seen one more lab program, that is listing of a prime numbers within a given range, and later on we have seen the storage classes. Whenever we are using a functions, we must be aware of the storage classes provided by the C programming language. So, in that we have seen the concept of automatic variables, register variables and the static variables. So, in this session, so we will be learning now the storage classes. In continuation to the storage classes, the one more type is there, that is external or global variables, and after that we will see the function call methods. So, C supports two types of function calling methods, that is call by value or the call by address value. So, based on the context, so the both are same. So, it is only one method what basically the C supports, that is call by value method. So, we will see that what exactly it is when we look into the concept of function call methods of C. Then we will see passing an array as a parameter to functions, how to pass an array as a parameter to function we will see, and then we will see a lab program, so which is to copy a string from source to a destination string, that is implementation of the strcpy, which is the library function, so available in string.h header. And then we will see the concept of recursion, and then based on that we see one more lab program of finding a factorial of a number and using the factorial of a number to compute the NCR values. And then finally we see the comparison of recursive and iterative methods. Now, so coming to the external or the global variables, so in the programming, so the keyword extern is used to declare an external variable, so or which are also called as a global variables. And so whenever we declare or define a variable outside of a block, outside of a, so all the functions, so that is the default scope of the variables or the function declared or defined outside of all functions block is a global. So normally within a block we declare a variable, then that becomes a local variable, and again it could be a static or register based on the keywords that we have used. And now if you are defining or declaring a variable or a function outside of the function, outside of all the functions, then the default nature of that particular variable will be a global variable, the scope will be global, and these particular global variables exist for the entire program execution until the program execution terminates, so or the ends. So these particular variables will alive. This means we can access those particular variables from every function. So every function can access these particular global variables because they are declared outside of all the functions. See, it is as same as say in the colleges, so there may be several departments in the college. So if you consider the notice boards, in each college maybe each department may be having its own notice board, that is like a local variable, and for the entire college there will be one particular notice board may be existing there, and that will be like a global variable, certain information that is to be passed on to all the branches of engineering. So maybe such circulars will be put in the global notice board, that is the one notice board which is really for the all the branches of the engineering discipline. But if the in certain cases each department will be having its own notice board, where the department related information will be so kept on those particular the departmental notice boards. So similarly here the local variables means within a function whenever we want to perform the operations we declare the variable locally, but when you want certain data to be communicated to all the functions, then such variables can be declared as the global variables. So here we may use extern keyword, or default scope of such variables which are declared outside of all the function block will be a global, and the default value of these global variables will be is 0. So the initial value, even if you are not initialized, the default value what the process will be the value 0. Now, so look at this particular program here. So here see I am declaring the three functions a, b and c, and which are not taking any parameter, so is void, and the return type of this function is also void there. And then so int x is equal to 1. Now this particular declaration, so here this value x is equal to 1, what I am doing the declaration here, this is not part of any particular functional block. So this is a global variable. I may use extern here, or without that also I can declare it, because by default the scope of this particular variable will be a global scope. And then so when coming to the main block here, main function, so again I have declared one more variable called int x is equal to 5. Now this is a local variable x, and this x has a lifetime within this particular main block only. But here what happens is we have the global variable also and even the local variable also. In that particular case the priority of the local variable will be more than that of the higher global variable here. Now the local x in outer scope of main is %d, x. So this x is printing the value of x as a 5 here, because so it is the local variable which is present within this main block. But again, if I am opening a block here, I am declaring one more variable called int x is equal to 7. So, this is possible that wherever we want we can have a block. So, in case of a C programming, not necessary that only in case of if else or in case of for looping or in case of function definitions you must use the block. So, opening and closing of flower brushes, it may be used wherever the programmer feels like, but it is recommended that where it is very much essential only then. So, we must use this opening and closing flower brush. But anyhow, to understand the concept of the scope and the lifetime of the variables, let us look into this particular block here. I am opening a block here, and here in the beginning of the block we are allowed to declare a variable in C. So, here again I am declaring int x is equal to 7. Now, you see here this is the local variable. So, again, so when I am printing the value of x here, local x in inner scope of main is percentage d comma x. So, here the value of x is printed as a 7 because within this block the local variable x is this particular 7. So, here we do not refer to either this x or to the one which is declared in the global scope. Now, once I come out of this globe, this particular inner block here, now I am trying to print again the x value. Now, when I am printing the x value here, x is equal to 7, what is there that has lost when the moment I come out of this particular block. So, this will print the value of x as a x is equal to 5. So, here these three printf will print the values as 5, 7 and 5 respectively, and after that I am calling the function a, b, c and then b and c. Now, if you look at the body of this function a here, what I am trying to do is int x is equal to 25. Again I am declaring one more variable called x and its initial value is 25. This is local to the function a here. Now, here this particular printf will print the value of a as a x. When it is entering to the function a, here the value of x is initially as 25, this will print 25. Then after that the next statement is x plus plus. When I do that, so x value is incremented by 1, it becomes 26. So, this will print the value of x as a 26 when I exit from the program. The moment when I exit from, not from the program but from the function, when I exit from this particular function, so the value of x will also die there because it is a local variable defined within this particular the function a. And now, so here, so after the function call a, we will be calling the function b there. So, when we call the function b, we will go for the function body of the function b. In the function b, we are declaring a variable x as an integer variable holding the initial value as 50 and it is declared as static variable, and static variables we have seen like they are initialized only once, but they persist their value throughout the execution of the program. Now, here when we print the value of x, it will print the value of x as a 50 and further x value is incremented, it becomes 51, and then so again we are printing the value of x as 51. So, when you are exiting from the program, the value of b was value of x in the function b, it is a 51 there. Then once we come back to this from the function b, will come back to the main function, then we will be calling here the function c. When you call the function c here, we will go to the body of the function c for its execution, and here the local x in c is percentage d after entering c. Now, here you can see that here we do not have the local variable. When you do not have the local variable, we look in the global space. So, when you look in the global space, in the global declaration we have seen that x is equal to 1. So, here the function c will print the value of x as a 1. After that, what I do is x star is equal to 10, means x is equal to x into 10. The current value of x is 1 there. So, 1 into 10 is 10. So, the x value, new value what x will get is 10. So, here the local x in c is percentage d after exiting c. So, here local x means c is referring to the global variable only because it is not having the local variable. So, x will print the value here, the x will print the value as a 10 here. So, first here the value of x will be 1, and in this case when exiting from the c, so the function c, the value of x will be 10 over there. Then again after the function c, again we are going to call the function b. When we call the function b here, again you can see that in the previous case the static int was initialized, and they are initialized only once because they are the static variables, and when it is exiting from the function b, the value of 50 was, so x was a 51. Now, when it executes this printf function here, the value of x will be printed as a 51. Then afterwards again xy is incremented, it becomes 52, and then the value of x printed here with this printf statement as a 52 there. Then after this, when we come back to this main function after the execution of the statements of b, again the function c will be called. When the function c is called, this since it has used the global variable, it does not have the local scope of x. So, the local x in c is percentage d after entering c. The previous case the x value was 10, so because that was a global variable applied in the global memory area. So, here the x will print the value as a 10, and again x is equal to x into 10. So, when it is updated, 10 into 10 is 100. So, here we get the value of x as a 100 while exiting from the function c. Then after that, coming back to the main function, no more statements are there, return 0, we exit from the main function. So, here, so these these are the possible values, so which gets printed on the screen. So now these are the possible values what we get here with respect to the first 3 printf statements of the main function. So here we get 5, 7 and 5 as the value. So here is the reason we get 5, 7, 5. And when we are entering the function a for the first time, so here, so what we get is the value of locally declared value of x is 25, and then it is incremented by 1, it becomes 26. 25 and 26 are the values what it is printing here, 25 and 26. And then when you call the function b there, so then here it is static variable, so the value of x is 50 and then it is 51. So here the 50 and 51 are the values of b. Then when you call the global variable, so when we use the global variable x in the function c, what c will print is initially the value of x was 1, and then when it is multiplied by 10 it becomes 10. So 1 and 10 are the values what the function c will print. So here global x is 1 on entering c, and the global x is 10 on exiting c. So in the case of function c there, so here when I am printing it, so this particular, it is not local, it is a global variable because it is accessing the global variable. So then, so here the value of x will be 1 and 10. So again, once again when I am calling the b and c there, the respective outputs are, so here with respect to b, so it is 51 and 52 because it is the static variables. So when the second time when I enter here, while exiting from the b in the first case it was 51, second time when I enter b here it will be 51, and while exiting it will print the value as 52 there. So is the reason 51, 52 is the outcome. Now with respect to the function c, so since it is a global variable, the value of x was 10, so now it will print 10, and again it is multiplied by 10, so we get the value as 100 there. So here we get 10 and 100 on exiting from the function c there. This is the kind of output what you get. So these particular 4 kind of scopes what is available in c, that is local variable or a register variable or the static variable and the global variables. So you must use so in a proper way when we are programming it. But you see another function here. So another program so which uses the global variable. So here int ab are declared the global variables, and I am using one function called void swap. So here I am taking the values of a and b, reading the values of a and b. I am reading it as a is equal to 15 and b is equal to 27. So before I swap means exchanging the content of 2 variables. So here I am reading the values of a and b, 15 and 27 will be printed, and then I call the function swap here. So what exactly I am doing in swap is I am exchanging the values of a and b. This is a declaration. It is not taking any parameter and it is not returning any data there, but the thing is it is accessing the global variables because global variables can be accessed by every function. Now after swap, a is equal to %d, b is equal to %d, a and b values I am going to print there. But what exactly I am trying to do in swap now? So here, so a and b are the global variables, they get the memory allocations. So 64,008 some memory address where exactly a is stored and the b values are stored. Now when you look into the function body of the swap function, in the swap function I have these many statements: int t is equal to a is equal to b is equal to t. So these are the statements which I am using for swapping of the 2 variables. Now t is a local variable what I am declared, but here a and b are the global variables. So swap can access those variables, so the addresses of a and b remains the same. So a swap function can access this particular memory area. Now the t is holding some junk value here because it is a local variable. Automatic variables by default hold the junk values. Now when I execute the statement t is equal to a, then what happens is a value will be assigned to the t. The t value was a value will be assigned to t. The t was holding the junk value, a was 15, that will be assigned to t there. Now when I execute here, a is equal to b value, again the b value 27 will be assigned to 15. So you can see that the a will get the value as 27. Now 15 is not lost, it is present in the temporary variable t. Now when I execute the statement b is equal to t, in the next case what will happen is the t value will be assigned to the b. T value is 15, that will be assigned to b. Now as a consequence what you can see is a will get the value 27, b will get the value of 15. Now when I come back to this particular program, now after the swap function what I was having is after swap a is equal to so %d, b is equal to %. I am printing the values of a and b. But now what has happened is the a value has become 27, b value has become 15 there, so they got exchanged. So here I will be printing the value as a is equal to 27 and b is equal to 15. So this is the way how exactly the global variables can be used here. But when you are using the scope, and this is the kind of output what we get, that is after a and b as 15 and 27, and after that the values have been exchanged here. A is 27 now, b is 15, and in the second run we can see like a is 37, b is 91, and then after swap we can see like a is 91 and b is 31. The values got exchanged there. Now but here certain recommendations we must keep in mind. So when we are using the storage classes of C language, so that is here use as much as possible less declaration of variables. So in the programming it is not like we can declare any number of variables. Of course we have the freedom of declaring any number of variables, but the thing is it is recommended that you must use as much as possible less number of declarations. So then avoid using global variables unless it is inevitable. We should not use the global variables. Fine, this is recommended that we should not use the global variables. The reason is like, so if you are using more global memory area, there is a possibility that some other functions may access the data and they can modify the data, and hence so there may be a chance like the data what we are expecting may not be exactly what it is present in the memory areas. Means all the functions can execute access those particular global variables. Because of the security issue, we say that we must avoid using the global variables unless it is inevitable. So there are certain situations where global variables are mandate, so is that so we have to use the global variables, but we should not make it a practice like the global variables must be used every time. So it is like even in the department notice boards, what we want to paste the circulars. So fine, that has to be good if they are pasted in the, or if they are placed in the department notice boards. But if all the departments try to place their notices so in the college notice board, then it could be difficult for handling the situations there. So this is the same scenario even here also. So locally, if you want a function want a variable, they can declare it locally, but they should not so declare all the variables as a global variables. And also in case of certain situations where if a variable is very frequently accessed and a many number of times, then in such cases we must declare the variable as a register. In case of looping constructor, in cases like for I is equal to 0, I less than 100 or I less than 1000, I plus plus, I will be accessed 1000 times very frequently there. Instead of declaring it as a local variable, declare it as a register variable, so that the execution of the program will be faster. These are the recommendation we should keep in mind. So when you are using this particular concept of functions in programming. Now, so with respect to the function call methods of C, basically the C language supports two types of calling functions. One is by call by value method, the other one is by call by address. So here many authors will specify this as a call by reference. So make note that so C language never supports call by reference. The reason is like reference types are another type of data where so we can use in C++. Once we have the reference type of data, only then we can have the concept of call by reference. But here the C language supports only one method, that is call by value, and of course the modification of call by value we can do to get another method called call by address value. So this particular call by address is indirect way of accessing the memory content, but it doesn't mean that it is a call by reference. Call by reference is a different concept wherein C++ supports it, whereas C supports only call by value, and the modification of that in some situation we call that as call by address. So you will get to know that what exactly the modification we do there. Now with respect to the call by value method, we will see that the values of actual parameters are copied to the formal parameters. So here in this particular method, the values of the actual parameters are being copied to the formal parameters here. It is a copying. The actual parameters are copied to the formal parameters. Formal parameters definitions what we have done in the function definition. Actual parameters is parameters what we are passing to the function call. Now, so consider this particular function here. So here, so the swap is a one particular global function. What I am declaring, it is taking two parameters here, and here I am taking the values of a and b, and before swap I print the values of a and b, and here I am passing a parameters. Here the values of a and b what I am passing, these are the actual parameters. And when I am going for defining the swap function, and before that you see that the value of a is 15, b is 27, I am entering the value of a and b as 15 and 27, their addresses are so on so 58,800 and 59,390, let me assume. So here the value of a and b are copied to the variables which I am declaring the swap function. When I call the swap function here, passing the value of a and b, it is 15 and 27. When I go for the swap function here, I have int x and y. X will get the value of a, y will get the value of b. Here x and y are getting the copy of the data. So here a is address is 58,800, b is 59,390, and a and b are not seen to the swap function because these are locally declared in the main functions. When they are local, they cannot be seen by the swap function. So what happens is I am passing the parameter as a and b values there. So x will get the value 15, y will get the value 27, and the t locally I am declaring one more variable t in the swap function, so whose value is 23,459, which is the junk data there. Now, so when I execute the statements of this swap function, what will happen is, so when I execute t is equal to x, the value of x what is there 15, that will be assigned to a t there. Now the t will get the value of x, that is the x will get the value as 15 there. Now when I execute x is equal to y, so x will get the value of y, that is the 27 will be assigned to x. So this will be the situation what I get there. Now when I do y is equal to t, now the value of y will get the value of t. So now so y will get the value of t there, that is 15. So, now here x and y values got exchanged. In the beginning of this swap function, x and y values were 15 and 27, now it has become 27 and 15, and you can notice that this has not affected the values of a and b, which are the actual parameters. There is a change in the formal parameters, but not in the actual parameters. Now, after this execution, no more statements are there. We will come back to the main function. When you come back to the main function here, after swap a is equal to percentage d, b equal to percentage d, I am printing the values of a and b. When I print the values of a and b here, still the values are 15 and 27 only, means the changing of the formal parameters so is not affecting the actual parameter. They remain same as the original values. A is 15 and b is 27. It is not exactly the exchange has happened there. So, now, so here the output what we get is A is 15, B is 27. After swap also it is the same value. Even if I run for the different case, even after swap also A value is 31 and B value is 91. This is the case what exactly happens with respect to call by value. So, what we can conclude here is, here values of actual parameters are copied to the formal parameters. Fine. So, here we are copying the actual parameter value to the formal parameters, and what we can conclude here, like the changing the values of the formal parameter does not affect the actual parameter, since the values are copied there. So, whatever the modification I done for a copy of this actual parameter, that will not affect the actual parameter there. In the formal parameters, whatever changes I do there, that will not affect the actual parameter. Some cases it is mandated that whatever the changes I made in the formal parameter, that should affect the actual parameter. If in case if it has to affect the actual parameter, then we have to go for the indirect accessing of this particular the actual parameter. So, for that we have the call by address here. Instead of passing the value, what we do here is the address of actual parameter is copied to the formal parameters. Here also we are doing the copying only, but what we are copying is not the value, rather the address of the actual parameters. In case of call by value, the value of the actual parameters are copied, whereas in case of call by address, the address of the actual parameters are being copied to the formal parameters. See here, when your address are copying here, who is capable of holding the address? It is only the pointers which can hold the address of a particular variable. So, now look into this particular function here. So, here int star and int star, these are the two types of data what the swap function is taking here as the parameter. Int star means pointer to an int, and again another case is pointer to an int, because here the address of A and B I am passing here. See the call to function swap here. In the previous case it was difficult, but in this case I am using it as a swap ampersand A and ampersand P. In the previous case we can see like, so here I am just calling a normal variable. So, A and B values I am passing it, because this is a call by value method, and here the declaration of the parameter what swap is taking is normal integer type, 2 integers, and return type is void for the swap function. But in this case what is happening is, so here I am passing the address of A and the address of B there. Now, so here what happens is, so A is address is 58,800 and B is 59,390, let me assume, and the values of A and B as 15 and 27, and now so the values of A and B before swap it will print as 15 and 27. Now, when I go for the swap function here, what exactly happens is, so I am declaring a variable as x and y, which are pointers of type int, and y is also pointer of type int, but what x is holding? X is holding the address of A, so that is 58,800 is the value of x, y is holding the address of so B, that is 59,390 is the address of B. Now, when I execute the statements here, t is equal to star x means what here? The value at address x, the address, what is the value of x here? 58,800, the value at address 58,800 is the value 15 there, so the t will get the value as a 15. So, now when I execute this here, value at address of x 58,800 is equal to 15 there. So, is the reason that t will get the value as a 15 there. Now, in the next statement what I have, star x is equal to star y, value at address 58,800, this particular value equals to value at address y. So, what is the y address here? So, 59,390 here. So, here value at address for 59,390, whatever it is there, that will be copied to A in the next case. So, you can see that the B value whatever it was there, the value at address 59,390 is 27, that has been copied to A indirectly. Fine, through the x I am indirectly accessing the content of A here. Now, in the next statement what happens here, this particular y is what? The value at address y, that is 59,390 is nothing but 27. When I use star y, y value is 59,390, but star y means it is 27. value at address 59,390. Then finally what I do is value at address 59,390 star y is equal to t. What is the t value there? 15, that will be assigned to the b value indirectly. Again here the with respect to the execution of the last statement, what happens is star y is equal to t means value at address y, that is 59,390, value at address 59,390 is equal to t value is 15 there. So here the b value will get the value as 15. Now after execution of this, so when I come back to the function here, I will try to print the values of a and b. When I see the values of a and b, they got exchanged here, because this is the call by address value. So people call this as call by reference. It is not a call by reference, rather it is a call by address value. So now, so here when I execute this one, a is 15, b is 27, so a is 27 and b is 15, it is got exchanged. And again here also a is 37, b is 91, and here after swap, so we get a is 91 and b is 31, so they got exchanged there. Now so what we can conclude here is the address of actual parameters are copied to the formal parameters, and hence the changing the values of the formal parameters affect the actual parameters. Changing the values of the formal parameter mean indirectly you are changing the values of the actual parameter only. So is the reason the changing the values of the formal parameter seems it is affecting the actual parameter there. So this is what we can come to a conclusion. Whenever changing of formal parameter do need to affect the actual parameter, then you have to go with the call by address method. Now, so we will see so how to pass an array as a parameter to a function. So the reason is, so when you are passing the array as parameter to a function, you must make use of the pointer concepts here. It is a call by address value only. Now arrays are implicitly treated as constant pointers. Whenever we are using an arrays, even though you are not aware of the pointers, it means that you will be using the concept of pointers there, because arrays are implicitly treated as a constant pointers. Fine, because it is a homogeneous collection of elements which are accessed sequentially. Fine. Now, so array elements can be passed as parameter to function in two ways. When you are passing array as parameter to function, we can pass it in two ways, that is passing an element by element. So if there are 10 elements, I can pass one by one each of the elements of an array, or pass the whole array, completely all the 10 elements in one shot I can pass it to an array. So these are the two different methods how the arrays can be passed to a function. We will see how exactly this can be done. Now look at this particular program to read and print one dimension arrays using user defined functions and global declarations. Here I will be using the global declaration. It is recommended that we should not use the global declaration. The global declaration simplifies the programming, but it's complicated in certain situations. Fine, so it is a security hole. So here it will not be insecure when you are using the more and more global declarations. But anyhow, so we will see how exactly the arrays can be handled using the user defined functions and the global declaration. Now here you can see, like I am using one function called a read array, which is not taking anything and which is returning nothing. Similarly, the print array is also which is not taking anything and which is returning nothing there. Two user defined functions, read array and the print array. These are the prototypes. And then I am declaring two global data, x of 50 and n. So n is of type integer and x of 50 is x is an array of 50 integer elements. Now here I am requesting for enter the number of elements of an array. I am taking the data n, and you can see that this x and n, the array of 50 integer elements x and the integer n is visible to all the functions, read array, print array and even to the main function also, because the scope is global scope. Then after that I will be calling a function read array, and then I will be calling the function print array. Get ch return, I am closing the main function here. Here I have the closing flower brace there. Now when I call the function read array, what exactly I am trying to do in the read array? In the read array, what I do is I take a local variable int I. So then I am requesting for enter %d elements of an array n. So here you can see that n is not here, but still, so this is not a wrong statement. N is the global data. So when locally n is not there, it will access the global data, and based on that, so it will print the value there. Now here, whenever I am printing the n value here, that is updated in the global memory, global data n. Now here psi is equal to 0, I less than I plus plus, scanf %d and x of I. I am reading all the values of the n elements of the array. So after that, reading the after executing all the statements of the read array, I will come back to the main function, and after the statement read array, I have a function called to a print array. When I go for the print array function, the body says like, so I am declaring on local variable int I, the %d elements of an array are n. So again the n value is the global variable is trying to access, and it will print that if I have entered 10, that the 10 elements of an array R is the display what we get there, and after that I is equal to 0, I less than an I plus plus. So print of %d x of I, the value of I will be printed over there. So value of array elements will be printed with respect to this particular code. So here I am closing the print array function here. After that it will come back to the, after printing the array, it will come back to the main function, and in the main function I have get ch return 0 and then closing the main function. So with this, so I have read the array elements using a function, and also I am printing the array elements using this particular function there. But here you can see that I am using the global data there, but it is recommended that we should not use the global data there. Now we will see the same program in a different scenario. So that is program to read and print one dimensional arrays using user defined function by passing an array element by element. Here we pass the array elements one by one. Now in this particular case I am using one function called a print array. It is taking integer data as the parameter. Here you can see that a print array what is there, and here I am passing element by element to this particular print array function, and print array is definition I am defining here. I am not going the declaration. The C language rule is like, before I call a function, the function should be declared or defined here. So void is the return type, the name of the function is a print array, it is taking integer as a parameter, then it is printing that particular value there. So this is integer n is a local variable of this function print array. This is a parameter what I am passing. The parameter are also treated as the local variables of the function there. So user defined function. Now here locally I am declaring within the main function 50 array of 50 integer elements n I, and then so I am reading the number of elements. So n value is a local variable, then I am reading the value of n elements of an array using this looping construct. I is equal to 0, I less than an I plus plus scan of percentage d ampersand x of I. I will be reading all the n elements. Now to print the elements, what I do now is the percentage d elements of an array are, so here for I is equal to 0, I less than an I plus plus, print array of x of I. When x is I is 0, x of 0, 0th element is passed. X of 0 is an integer element, whereas x is an array. Fine. So don't get confused here. X is a name of an array, whereas x of 0, x of 1, x of 2, all these are individual integer elements there. When I is 0, I will pass x of 0, and that x of 0 will be copied to n here when I call the print array function here, and here I am printing that particular value of x of 0. Again I will come back to this main function. Again I value is incremented, I becomes 1, 1 less than n, again x of 1, print array of x of 1. So when I call x of 1, print array of x of 1, x of 1 is copied to n, and it will print again the value of x of n. So now again after execution no more statements are there in the print array. I will come back to this main function. Again the I value is incremented. So now again 2 is less than n, and again it will call print array of x of 2. This process will continue until I value is less than n. So now element by element, all the elements of an array I am going to print there. But this is not the recommended method of programming when I am using array as parameter to a function, because here if there are 100 elements in an array, 100 times I need to make a function call. Functions are function makes the programming easier, but thing is like we should avoid even the functions also. So we should not use very frequently the more number of functions in the program, right? So the execution of function is also, it will take more time and space. You will see that when you see the concept of recursion there. Now so here, so what we are doing is we are element by element we are going to pass the so value, and we are using the user defined function, we are printing the element there. So instead of that, what we can do is like we can pass the entire array as parameter to a function. Now so this is the program where we read and print one dimensional arrays using user defined function by passing the whole array as parameter there. Now you can see like read array is the name of the function here. Now the two parameters it is taking here, int star and int. I told that array are implicitly treated as a pointers there, and when they are pointers, and to hold the base address of the array you must declare a pointer over there. So here is the reason int star is the first parameter, and the second parameter says number of elements in the array, that is specified with the second parameter. I don't have any global data here, all the data are locally declared within the main function there. Again for the print array the same, it is also taking array as a parameter and number of elements. You see that I can use here int star or int opening and closing square bracket. This is syntax what I supposed to follow when I am passing an array as parameter. I can use int star, or I can also use int opening and closing square brackets. So this is only for passing one dimensional array as a parameter here. Fine. So here int x is equal to 50 and n so is a variable of type integer. So here x is an array of 50 integer elements. So x is an array of 50 integer elements. N is an array of n is a normal variable of type int. Next here I have one statement here, enter the number of elements of an array, reading the value of n, and how I am passing the parameter you can see there. So read array x comma n, I am not passing the element in an array, rather I am passing the name of the array. What exactly the name of the array holds? We have seen that when we discuss the concept of pointers, the name of the array will hold the base address of the array, and hence so x is the base address of the array which I am passing it as a parameter. Since it is an address, who is capable of holding the address? The pointer. So is the reason the parameter, what the first parameter of a read array function, we have declared it as a pointer type. The second one is the number of elements of an array. That is also mandate for reading the elements in the array. So here the second parameter is of type integer, so is the reason the second parameter is int here. Now again, after reading an element, I go for printing the array elements, print array x comma n. Again here x is an base address of the array, so here we can see that the first parameter is a pointer. I can declare int star, or I can also use int, then opening and closing square bracket there. This is the way how exactly I can declare the functions when I am passing array as parameter, one dimensional array as parameter. Passing two dimension is quite different. We will see that in the next programs. So after that we get ch and return. So what exactly we do in the read array function, we will see. Now only thing is here int star p I have created, and then int n. Rest of the code is same here. Int I, enter percentage d elements of an array n. For I is equal to 0, I less than I plus scan of percentage d and p of I. I am exactly using as that one dimensional arrays only here. Only thing is here I am declaring it as a star p, because that is holding the base address, and until the value of n is reached, so I will be reading all the elements one by one, and this all the elements what I am going to read here, that will affect in the array x, because it is a address what I am passing here. So though the value we may place it here, we are read from the read array function, but the reflection what we can see is in the actual parameters, because here addresses are passed here. So and hence here changing the content of this, staying in this particular function read array, will be accessing the elements of x array, fine, because x is p is holding what, the address of the base array x. So is the reason this is the case what exactly is happening there. And then when you, after reading all the n elements, we come back to the function, then we go for the print array function. When you go for the print array function, here we can see that we are printing the elements of an array here. So again the same statements, the normal way how we exactly we use, the same way we can use here. Only thing is function, so parameter is bit change, and here we have the function user defined function here. The void print array is the name of the function, int a opening and closing square bracket. Here I am not mentioned any size there. Even if you mention also it will work, fine. So normally we do not write anything there, because here the base address of the array is passed there, fine. And how many elements I supposed to access there? Only the n elements. If I try to access n plus 1 element, then I get some error. Array boundary access problem will be the problem that get arised when I try to access the elements outside the boundary. So here using this a, so for n elements 0 to n minus 1, I will be accessing the elements, and I will be printing the elements of an array. So this is the way how I can program, so by passing one dimensional arrays as parameter to a function. Now so we will see one example here, program to read an array and search for a given key element using the user defined function. That is, here we perform a linear search. So here the name of the function is one function, user defined function is read array. It will be reading an array of n integer elements. So this is a prototype of the function, and I am using a function called linear search here, along with the base address p, which is the pointer to int. So it is taking first parameter, the second parameter is n, the number of elements of an array, third parameter is key, the key element to be searched there. I take the local variable int I, then I is equal to 0, I less than an I plus plus. If p of I is equal to key, each of the elements of an array I am searching one by one. If the key element is found, I will be returning 1. So otherwise, so here I will be returning 1, I will not be in the function only, I will return back to the main function. In case if the key element is not present, I will be coming out of the loop. When I come out of the loop, I return the value as 0, indicating that the key element is not found there, right. So now in the main function, what we see is these are the statements. So x is a locally declared array of 50 integer elements, n, key and flag. These are the variables what I am declaring as type int, and then I read the number of elements, then read array x comma n. X is the base address of the array, n is the number of elements. The read array function will read all the elements of the array, all the elements of the array x. So here the read array function definition I am writing here, and here I am reading all the elements of the array x there. So here a is the pointer of type int, which will hold the the base address of the array X there. So, now after reading all the elements, we will come back to here and then enter the key element to be searched. I take the key element and then flag is equal to linear search of x comma n comma key. See here x is the base address. So, first parameter should be pointer, n is the key element to be searched, sorry, n is the number of elements and key is the key element to be searched. So, in the correspondingly how it is defined in the function, the same way we are supposed to pass the parameter, fine. So, now after this, the linear search function will return the variable flag, so return either 1 or 0, 1 when the key element is found, 0 when the element is not found. So, when flag is equal to 1, we say that successful search. Similarly, else means the print of unsuccessful search. If the key element is not present, we print unsuccessful search. So, we return from the main function. This is the way how exactly we can program to find a particular key element in an array of so one dimensional array of elements using the user defined function. Now, so this is the read function what I have defined. Now, we will see how to pass a two dimensional array of elements into the user defined function now. So, here, so when you are multiplying the two dimensional two matrices, so we must see that the number of columns of the first matrix should be equal to the number of rows of the second matrix. This is one of the lab program, but here we are trying to do that. So, multiplication of two matrices in the using the user defined function. Now, this is the syntax here. You should follow only the syntax. The syntax will change. That's it. Function call and function declaration, and from the way how we are passing the parameter. This is quite different here. Int star 10 is different, int star within the parenthesis and then 10 is different. This is the 10 represent the column, whereas the first star represent so the addresses here. So, here the int star of 10 means it is a collection of it is holding the base address of the an array of 10 integer elements, right. This is the same thing. The int star of 10 means it is a pointer to an array of 10 integer elements. If I say int star of 10 within the parenthesis, it mean like, so it is an array of 10 integer pointers, whereas this is star within the parenthesis will say that. So, say here, so it is a pointer to an array of 10 integer elements. There is a quite a difference there, and here we say that this first subscript represent the rows, second subscript represent the column. So, here the second subscript is mandate when you are going for the prototype or even in case of the definition here. So, again I am using the read matrix here. So, again the first row is not mandate, the row size, whereas the column size it is a mandate that we must mention the size of the column. Now, here int and int I am taking two more parameters of type int, because when I am reading a matrix, row and column size is also required there. So, the order of the matrix, the other two parameters. Now, in case of multiplication, we require three other integer data there. This is for the matrix A, this is for the matrix B, this is for the matrix C, and here this is for the M and Q and the another parameter N. So, based on which we perform the matrix multiplication. Now, here if we look at the print matrix here, what exactly we try to do is P is an two dimensional array here. P is, in other words, P is taken as a pointer to an array of 10 integer elements. So, M and N are the rows of the rows and columns of the matrix which I am going to read there. So, here the reading is same here. For I is equal to 0, I less than m I plus plus, j is equal to 0, j less than n j plus plus, print percentage d p of I j. Here I am printing the matrix. This function is to print the matrix and this function is for reading the matrix. I am just defining that print matrix here itself. See that before I make a function call, the function should be defined or declared. Just for your reference, I am defining it here. It is recommended that first you have to give all the declaration, and after the main function we are supposed to define the function. Now, this is the function for read matrix. So, in case of read matrix, what I do is P of 10 10. So, here basically this is a pointer to an array of 10 integer elements, fine. So, each one dimensional array is an two dimensional arrays are array of one dimensional array. So, is the reason. So, number of columns specified in the two dimensional array, that must be compulsory when you are mentioning the, when we are passing as a parameter to a function. Int m comma n, the other two parameters there, then based on the parameter rows and column size, we will be reading the values of the elements of the matrix, scan of percentage ampersand p of I j. So, I will be reading the elements of the matrix. And so here I will be reading the elements of the matrix, and if I am reading three matrices, I can read the same function. I can pass based on the addresses, changing the address and the values of the parameters, I can read the matrix. So, you will get to know when we use the main function here. Here you can see like A is an array of 10 rows and 10 column matrix, B is another matrix, C is another matrix, M, N, P, Q are the order of the matrices. I will read the order of the matrix M and N of matrix A. Similarly, I read the order of the matrix B, P cross Q, P and Q, and then if it is not equal, n is not equal to P, I display that incompatible order of matrices to multiply. Then what I do is enter percentage the elements of matrix A. I am reading the matrix A elements here. Now, when I am reading the matrix A elements, I am passing A, the base address of the 2-dimensional array A, and then m and n are the parameters of the function what I am passing here. M is the rows of the matrix A, n is the rows of the matrix B, columns of the matrix A. So, here I will read the matrix elements A. Then I am calling the requesting for enter percentage the elements of matrix B, P into Q, those many elements are present in matrix B. So, here B is the base address of the 2-dimensional array that I am passing as the parameter here, first parameter. Then P and Q are the order of the matrix P. I am passing that also as a parameter there. Then after that, reading the matrix A and matrix B, I am calling the matrix multiply function. What are the parameters I am passing? A is base address of array matrix A, B is the base address of matrix B, C is the base address of matrix C there. And after that, I am passing M, n and q. These are the three parameters which are essential for performing the matrix multiplication. See the code corresponding to this. So, here only thing is declaration is changing there. This logic of computation remains same as per the normal procedure. Only thing is here we should say that int star of A means A is holding the base address of the matrix A, C here B is holding the base address of the matrix B, C is holding the base address of the matrix C. Here I can use any nomenclature. So, for easier reference, so I have taken here as A, B and C. This is a syntax to be followed there. If the parenthesis is not there, then again it will give an error. So, that is not the proper method of coding. So, here the parenthesis has to be there. Syntax we should follow very strictly there. Now, so after returning from there, so print the matrix A element using a print matrix A, and then we print the matrix B, and then we print the matrix C. See here I am reusing the code. I am using same function, but I am reusing many a times here. So, here also for read matrix I will use it twice, and print matrix I am using here thrice. So, I am printing the all the elements of the product matrix whatever I get there. So, I return from the main function. This program when it is executed, this is a kind of output what we may get. So, we read the order of the matrix A, matrix B, since they are it can be easily multiplied. So, what we are trying to do is this is a 3 cross 2 matrix, 2 cross 3 matrix. When we multiply it, so we get the elements here. So, this is the way how exactly it can be read. Now, so this is one of the lab program what is to be seen. So, write a C and execute a C program that implements the string copy operation. So, to copy a string from string 1 to string 2, we have to copy a string 1 to string 2. So, string 1 is the source and string 2 is the destination. Copy a string 1 to another string 2. Now, here this is the prototype of the function strcopy, and it is taking two parameters. One is const char star s. So, the source string should not be affected there. So, and then destination string char star d. I told that string is an array of one dimensional array of characters. So, here when you are passing array as parameter, take it as a pointer there. So, is the reason I am taking it as a pointer const char star s char star d, and return type of this strcopy function is char star. The base address after copying where exactly it is copied, that base address will be returned by the strcopy function. Now, so I read a string here with this particular statement, and then strcopy string 1 comma string 2. String 1 will be copied to string 2. Fine, string 1 is the source and string 2 is the destination. If I am using the library function strcpy which is available in the string.h header, I must use the function str2 comma str1, because the strcpy library function will expect the first parameter to be the destination, whereas the second parameter to be the source. But here what is asked for implementation is first must be the source and the second parameter must be the destination there. I read the string 1 and then I print the string 1 and then I print the string 2 after copying the content of string 2 to the string 1 to the string 2 there. What exactly I am doing in strcopy? In case of strcopy, what I am trying to do here is I am taking one dimensional array str1, I am taking one dimensional array str2 there. So, as the parameter there, so str1 is holding the base address of string 1, str2 is also holding the base address of string 2. Now, I is equal to 0, while str1 of I not equal to null character. Until we reach the null character, we have to copy every character from string 1 to the string 2 there. So, here I am copying from str2 of I is equal to str1 of I. I am taking all the characters one by one from string 1 and I am storing it in string 2 there. Since I have declared it as a const character, because the source string should not be modified. So, is the reason I am declaring it as a const char. So, this is the way how exactly it is defined in case of even in the library function also. So, after copying it, what happens happens there is, so after each copying I am incrementing the character I plus plus. So, I am going for the next character. This process I do until the null character is seen. When the null character is seen, when I have reached the null character of a string 1, so I have to terminate this particular while loop. I will be coming out of the while loop. When I come out of the while loop for string 2 of I should copy this particular null character also. If it is not copied, then we cannot perform the printing of the string. So, this is mandate that string means what? As the array of characters terminated by a null character. This looping while loop will perform only the copying of character one by one. It will not copy the null character to the last position. So, anyhow I is pointing to the last position. So, finally we copy the null character to str2 of I. So, then finally we return str2. Fine. So, here str2 is what? Basically the base address of the destination string, right. So, str2 is a base address of the destination string, means it is a pointer. So, here the return type of the function is char star. Now, after returning from strcpy function, we print the string 1 and string 2, both has to be same there. This is the output what we get. If you are entering the string as VTU, then string 1 is also VTU, string 2 is also VTU there. Then, so we have to see the concept of recursion. Now, the concept of recursion is like a relation which is defined in terms of smaller instances of itself until certain condition is met. This is the recurrence relation in mathematics. Say for example, so factorial of a number we can define it as n factorial is equal to n into n minus 1 factorial there. Fine. So, now, so if you want to write the exact definition of this particular factorial, this is not the exact definition of a factorial. This is because here we do not have the trivial case. If it is a 0 factorial, has to be 1 there, right. As per the definition, it says that 0 factorial equal to 0 into 0 minus 1 factorial, and minus 1 factorial will be equal to minus 1 into minus 1 of minus 1 minus 2 factorial. But we do not have the factorial for the negative values. The exact definition of recursion is like, for the factorial is n factorial is equal to 1 if n is equal to 0. This is the trivial case. So, otherwise it has to be n into n minus 1 factorial in case if n value is greater than 0 there. Now, so this is the exact recurrence relation of the factorial function. Here we are defining factorial in terms of itself only. So, is the reason which is a recursive definition. Fine. If you use this, then how to program it? So, now here instead of calling it as n factorial, I call this as a function. So, fact of n, so which is equal to 1 if n is equal to 0, which is a trivial case, and it is equal to n into fact of n minus 1 if the n value is greater than 0 there. So, this can be easily programmed. So, if you are using this function there. So, a fact of n is a function, n is of type integer there, and we have to return 1 if n value is 0, otherwise we have to return n into fact of n minus 1. So, now this is the function body. So, name of return type of the function is int, name of the function is fact, taking integer as a parameter there. If n is equal to 0, I am returning 1, else I am returning n into fact of n minus 1. You can see that the function fact is calling function fact only. So, this is a situation where a function calls itself, so until certain condition is met. So, what is the condition here? The n is equal to 0 means I am returning 1, I am not calling the fact again. This particular technique is called as a recursion, a technique in programming where a function calls itself until certain condition is satisfied. So, this is called as a recursion. Now, this is a recursive function to compute the factorial of a number. Now, the same function I can write even a non-recursive method. Non-recursive method means, so here, so this is another function, the name is fact, taking integer as a parameter, return type is also integer, and here what I am trying to do is if n is equal to 0, I return 1, else int I product 1. So, I is equal to 2, I less than or equal to an I plus plus, product is equal to product into I. I am going to do the multiplication in an iterative method, n number of multiplications. It is same as, so multiplying 3 factorial means 3 into 2 into 1. So, this is how I do here, 2 into 1 into 2 into 3. If it is 5, then 1 into 2 into 3 into 4 into 5. The finally I will be returning the product of multiplication, repeated multiplication, what I do there, the factorial value that I am going to do. So, this here I am not using a recursive function call. A function is not calling itself here. So, this particular method we are calling it as the iterative method. Now, having known this particular factorial function, so here we have one lab program to compute the binomial coefficient of a number. So, and we have to tabulate the results for the different values of n and r. So, for when you are computing the NCR, when you are computing NCR, we know that formula is n factorial divided by r factorial into n minus r factorial. We can make use of this particular function in defining this NCR. We can see like fact of n, we can define it as if n is equal to 0, return 1, else we have to return n into factor of n minus 1. This is the definition of the factor. And definition of the NCR, how we can define is, I can call a function name as find NCR, return type is integer, taking two parameters n value and the r value. What it's supposed to return is fact of n divided by fact of r into fact of n minus r. And I am using one more function here called, so this is the function of NCR, and then I am using one more function called int minimum, which is taking two parameters and returns so minimum of x and y. If x is less than y, return x, else return y. This is a ternary operator what I am trying to use, because this is necessary in the computation of NCR values. When you are tabulating the different values of NCR for the given value of n and r, this is mandate there. And if you look at the main function here, I am declaring here the three variables n, r, i and j here. So n and r are the two values of NCR, and then for I is equal to 0, I less than an I plus plus, I am tabulating the result for various values of n and r here. So j is equal to 0, j less than or equal to minimum of I and r, so j plus plus, here result is equal to find NCR of I comma j, and then I am printing those particular values here. Fine. So this is the way how exactly I am calling in this particular program, and the output what we can get here is, when I enter the value of n as 5 and r as 3 here, so NCR of 0 0 is 1, 1 0 is 1, 1 1 is 1, and similarly 2 0, 2 1, 2 2, and all those stuff. Fine. So here the main thing is like why I am using this minimum of I and r. Fine. So when I value is 0 here, I cannot compute 0 C1. Fine. So we cannot have the values for 0 C1. So we supposed to, so we don't have the negative factorial values, so it has to be minimum of I comma r. This is the expected result what we can so get here. So finally, so instead of factorial, I leave it as an exercise. And now, so I just give a comparative study of recursion, the iterative method. Recursion will take more amount of time and space for its execution. Fine, because of the repeated function calls, it will take more time and space, whereas the iterative method will not take more time and space. So it is recommended that we should not use the recursion because it is very expensive in nature. Fine, so we should avoid using the recursion wherever it is possible. Recursion is easy to program, but the thing is, it is a very expensive one. It will take more amount of time and more amount of space. Fine, so here I conclude this. So thank you. ಇವತ್ತು ಎಷ್ಟು ಫಾಸ್ಟಾಗಿ ಹೋಗಿದ್ದೀನಿ.